All right. Vinay Srihari is a Snowflake field CTO in the global sales engineering organization. He is responsible for promoting adoption of the data cloud and synthesizing customer input to guide product direction. His passion is bringing technology and solutions to the market that deliver lasting customer value.
Perfect. Well, I am happy to be here and to close out the day for everybody. So we're going to talk about cross-domain sharing in the Snowflake Data Cloud today. So moving into the key point of this presentation, I think, is going to be data silos, and you know, that's the piece we're going to focus on, and it's our belief is that companies are really falling short of realizing the full potential of data because of the proliferation of these data silos. So there's a study done by Forrester about 87% of firms wanting to expand their ability to source external data. And the concern is with the rise of application clouds like Salesforce and Workday, you know, and infrastructure clouds, sort of like the AWS, Azure, and Google Cloud setups. The amount of data we have to drive these businesses has exploded. But what's really happening here is that the data is simply getting siloed across different environments. And with the cloud, what we're seeing is that the amount of those silos are just shifting to the cloud. So the public cloud is not really solving that problem. And of course, we have all kinds of data, from weblog data to IoT to the standard enterprise apps, finance. That's not going away. So in terms of technical challenges here, so we have, you know, we can really distill this down to three. The first one is that data is siloed across companies. Governing and securing those copies of data is extremely difficult. And we have data pipelines that are slow, processes that are complex, fragile, and sort of all of this is getting exacerbated by the scale of data. The data cloud is sort of an extension of the application and infrastructure clouds that we have. And at Snowflake, the way we define the data cloud is essentially with these two key elements. There is a data platform that provides the architectural design and framework to connect businesses and to connect data within a business. And then there's the actual content. So providing the most relevant, valuable content that populates the data cloud and can be mobilized, you know, to drive better decisions. And these decisions lead to better products, services, and better business outcomes. So the data here includes the data from customers, from partners, from point of sales, machines, and of course, internal data that the company has themselves. So let's explore both the platform and the content here. So the Snowflake platform itself is a unified architecture. The idea is that you have data sources on one side, data consumers on the other side, and you have a whole bunch of workloads that you're applying to this. And those workloads could be traditional data warehouse type workloads for business analytics, manufacturing analytics. We'll look at an example. Data engineering, certainly a data lake where all of the data is structured, semi-structured, and unstructured are sort of located. Applications built on the data that deliver customer-facing products. And then data sharing, which is the piece we will focus on here today. And there are three layers to this platform. There's the elastic performance engine that provides the technology to run queries, to make observations, to train models, to deploy machine learning sort of models and techniques. There's an infrastructure layer that allows for the rapid scale up and scale down, the pay-as-you-go type economics. And then the Snow Grid, which is what connects all of the players in the data cloud. So digging down into Snow Grid, Snow Grid technology is the connective tissue. So it's Snowflake is a sort of a managed service model. So we deploy in all the three public clouds, AWS, Azure, and GCP across the world. So we have 28 different regions across the world where we have deployments. So you're allowed to share live, ready-to-query data, cross-cloud, cross-region, without any ETL. So no matter where the data is produced and processed, it can then be shared. Then you have a unified governance layer, which is really important when you have things like data regionality. So sovereignty of data is critical. So the ability to control what it is you're sharing down to the level of a row, down to the level of a feature in a ML model. And then the ability to co-process, so to have two parties that can securely share. You have a notion of a double-blind join, which we'll look at a little further down. So I thought I'd dive a little bit into how secure data sharing actually works. So if you look at a single deployment, let's say this is Azure's East region public cloud deployment, and you have a provider, a chip fab manufacturer, and you've got somebody who has the designs for that chip, a consumer, and the provider wants to share yield data with the consumer. If they're both in the same deployment, there is no data movement. So it's essentially we're leveraging Snowflake's multi-tenant architecture to be able to share a pointer to the data. And what you're sharing are tables, external tables, views, user-defined functions, so APIs. So this is not files. I mean, these are not individual, let's say, SDTF or DICOM files that you're moving around. These are actual tables. This is curated data. These are views. These are functions. And all of this can be shared without any movement and without latency. You can get a feed. You can also get incrementals on this. And what happens when you go, let's say, cross-cloud, right? Let's say your provider happens to be on Amazon's West region, and the consumer happens to be in the Azure Frankfurt region, let's say, for example. So it's the same basic principle that applies here. The provider can share within the deployment without data movement, but when there is a remote sharing requirement, there's a data replication step. This is all native to Snowflake. So it's compressed data, it's encrypted, and it's only the tables and the views that you've chosen to share with that consumer. And then there is a share replication step. So this is where you're sharing the definition of the objects that are a part of that share. And then there's the actual sharing that happens within the region. Sorry, let me just go back to that. So this is sort of the configuration for going cross-cloud and cross-region. And these are the steps involved. We do, of course, automate all of these steps. But I just wanted to make it clear that there is a local sharing or a within-region sharing aspect. And then there is a cross-region, cross-cloud sharing aspect that is possible. And for all of these, you can have entitlements. So for example, consumer X in Tango org here, might have a specific set of rows that they're allowed to see, perhaps for the chips that the fab manufactures for them. Consumer Y might have a separate set of rows. So you can build in that logic on the provider side and have it scale, essentially have it be dynamically filtered as the data is delivered with a common set of role-based access control policies. Right, so let's look at this, at a broader view. So what is the whole data life cycle that one might, sort of envision for a major enterprise or even a small company, a startup? So one aspect of this is getting your data out there so that it can reach the consumers and vendor and partners that you may not even know about. So there is the data marketplace. One example of that is the Snowflake data marketplace, where you can publish metadata describing the data sets. And that could be a sample, try and buy type of functionality. It could also be a paid listing, and it can be personalized. So it could be specific to Intel, could be specifically sharing data with let's say Ford Motor Company or with Tesla, supplying for their specific cars, or Global Foundries with one of their chip contractors, for example. So, in any of these cases, you can have a publish and a consume kind of relationship. But the consumer can receive the data, enrich it, and then reshare it with their own consumers, right? So that's all possible on platform. Now, what if there is a non-Snowflake customer? So participation in the marketplace is reserved for those with Snowflake accounts. But if you have, and it's quite likely you have partners and customers who are not on the Snowflake platform, you have the ability to spin up what's called a reader account, which is essentially an environment hosted by the provider for the use of the consumer. You can run BI tools, machine learning tools. You can point your Spark instances at this, any number of processing options. And then within your own organization, there's this notion of a data exchange, which is sort of a internal hub. And I think this was referred to by Michael in the previous talk. You can actually build this hub up with participation across the world, across all of the global regions, cloud regions across the world, and have this provider-consumer sort of, sharing of data that happens. So I'm going to pause here, Neil. Are there any questions I can take at this point on the fundamentals?
No questions at this point. We're good.
All right. So looking at an application of the data cloud concepts that we've talked about for Chiplets for data and test. So let's imagine that you're an organization that is, that has plant operations, devices, sensors, also your own internal CRM and marketing, and then a test and assembly sort of center or multiple centers all over the world, and then an ERP, a capacity planning system. This forms sort of the core, the inner core of your data. Right outside that, you've got the ecosystem of logistics and delivery partners, analytics partners, compliance, regulatory, and then maybe consumer-generated machine logs. So these could be IoT streams that are coming from the machines themselves, and then your distributor dealer framework and contract manufacturers. So that's kind of a trusted layer that sits right outside your core data. And then what a marketplace like Snowflake's provides is, a set of curated data sets that are offered by various agencies. And these are all examples of providers we have on the marketplace today. So you might have weather event data, global financials. Crux has some environmental and social metrics data, firmographics from Equifax. And then on the energy side, both S&P Global and Yes Energy have global energy market information. And this is all live data. So this is data that is changing by the hour, by the day. It's relevant, and it's data that you can blend with the inner layers of data, the ecosystem and the internal data. And the whole idea is to get insights about your processes, identify bottlenecks, and anticipate events that are happening. So this is what we refer to as that data cloud, or the content piece of that data cloud for manufacturing.
I have a question on that one.
Sure.
Do you have any specific examples you can relate of people using some of these kind of seemingly unrelated data sets to actually drive internal insights?
Yes, actually, I do, and I have in fact 3 customer examples. So if I could just ask you to hold on for a minute, sure. I will jump right to that. So some of the imperatives that we've seen across our customers in the supply chain, sort of, they tend to come down to these 3. So there's decreasing costs with materials and logistics. There's improving productivity, yield. We have Micron as a customer, and I'll talk a little bit about that use case. And then getting a 360-degree supply chain visibility to be able to move things around, optimize costs, right? So these are sort of the high-level imperatives. So an example of one of one of our longstanding customers is Komatsu. So Komatsu has a sort of had a problem with real-time IoT. They had streams of data coming in from their operators, from their technology and equipment services, so the machines that they run and manage for for their manufacturing customers, and these were coming in at a fairly high clip, so gigabytes, hundreds of gigabytes per day, per hour. And then they wanted to get this data to their data scientists to be able to generate predictive, sort of diagnostics and prepare for maintenance, sort of have maintenance cycles that ran ahead of the actual outages. And then performance data coming in from the factories, from the production lines. And so all of this information was coming in, was being duplicated, it was being sent around. So having a single system, that could process all of this information in one place and tie in information from AccuWeather, from, and then most recently, COVID-related data. So where was the virus spiking? What were the mobility? What were the recovery stats? So this is information that was changing, of course, on a daily basis. So Komatsu was able to blend, really build out those three circles. Start with the data that they owned, add in the data that they received from their partners, and then blend that with public data sets, that provided that broader aggregates to be able to predict. Micron, and I love this example because they're, of course, one of the largest chip makers in the world, DRAM, flash memory. They service customers across the spectrum: networking, storage, consumer electronics, computers, mobile telecom, you name it, printers, all of that. And they also generate about 90% of their sales outside the US. So they're truly a global manufacturing company. They're also highly data-driven, right? So they collect massive amounts of data from all of these processes, and using this data to help their engineers streamline and innovate their own manufacturing process was what they were struggling to do with and their constraint was uptime of their platform. So they had outages. I think there was a statistic where they had, over a period of 6 months, they had 2 or 3 outages that cost them millions of dollars in revenue. And so stability of their data platform was key. They also had won awards for being innovative. Their enterprise architecture department had won CIO 100 awards. So they clearly had the staff to do it. Smart manufacturing initiative and so on. So what Snowflake provided there was first of all, the Snow Grid technology was key to be able to connect all their consumers across the world to the analytics that were coming from their manufacturing systems that they ran on behalf of those customers, reducing downtime, essentially being able to scale, and cost. Cost was key. And I think if there was one item here, it was the reduction in downtime. That was a game changer for them. And I'm going to dive. This is a customer. I can't actually name the customer, but I did notice their the sponsorship list here. So we'll call them a network device company, and their particular use case was with component quality feedback. So they had contract manufacturers. There were several of them. Flex, Foxconn were 2 of them. They had a fairly complex data pipeline that had developed over the last 20 years, where the contract manufacturers were collecting data in the form of XML, JSON files, and then setting up FTP, secure file transfers to regional servers that then all routed to a central data center. So there was a complex data gathering mechanism from all of the actual manufacturing pipelines, and then sending that to the company. And then network devices themselves had their own devices. So they had DIMMs from Samsung, chips and ASICs from Intel, Seagate storage devices, all generating temperature data, sort of, were they running within spec, were they out of spec, And all of this, they wanted to send back to the manufacturers for root cause analysis to get reliability data that the manufacturer had about their own components, so that this device company could plan for predictive component replacement. And in doing all of this, despite the fact that they were a network company, their own network was choked by the amount of data that was moving around. So eliminating data movement was a significant problem. And they had some other issues where their quarter close was impacted because important metrics were missing, and the lack of controlled security and visibility. So these were all aspects of the platform, as well as the grid technology we talked about, that they were able to solve in a 18-month migration to Snowflake. I actually assisted with that migration, and the results have been sort of better than we had anticipated because of the level of sort of inefficiency that was built in over the last 20 years on this. So sort of on that particular topic, that specific company, some of you might have heard of this notion of a data mesh that has been making the rounds recently. It's a concept that was popularized sort of early last year, and the idea is that being able to bring all the data to one place to analyze it, is just simply not practical anymore, because there is a domain-centric aspect to data. So if you're a chip manufacturer, you have information about that process. If you're a consumer electronics company that needs to consume those chips and is using them and has, you've got failure information, that's information that you have about that. So information is owned by various domains, and that's not going to change. And each of these domain owners has knowledge about the data pipeline. Now, having said that, you still want to be able to provide the data as a product. So the case of Micron, they want to be able to provide manufacturing analytics information to their consumers and say, this is how our pipeline looks. This is our uptime record. This is how long this is our yield percentage for this particular kind of ASIC. And this is what you can expect from us in terms of shipment time, and sort of that level of insight into the manufacturing process is basically a product, an analytics product, but it's one that they want to offer and monetize. And then, of course, in order to do that, you need a self-serve infrastructure. So the days of a central IT team, that if you need a virtual machine, you got to go to this central IT team. They give you that resource, and then you've got to wait a week for that to get spun up. That's not going to happen. That's going to limit scale. So self-serve infrastructure, and finally federated governance. So everybody wants to be able to interoperate. Global interoperability is important, but data sovereignty is also important. So data that's in EMEA, that's in the EU, has very specific GDPR requirements, particularly if it's sensitive data. It's got either personal information or company information. The same goes for data leaving the US. So you have to be able to define what data you're sharing and have strict policies on how that data is governed, visibility into who's using the data, so on. So these are kind of the overall principles of a data mesh. And this is a reference architecture about how you achieve those in a data cloud. So a Snowflake Data Cloud, for example. So in this picture, each of these big rectangles here, are, for example, this one here is let's say an Azure Frankfurt deployment. Here you might have a Google Cloud deployment that's on the west coast of the US. Then Zurich might have another Azure deployment, and then you've got AWS Tokyo that has perhaps some consumer electronics information. And all of these domains have data product type information that they want to share in a common inventory. so that you can have people request and be approved to get access to that data. And that's where that's sort of a virtual central repository, because the data isn't actually being moved anywhere. It's being offered to the consumer. Once the consumer is approved, then we have that replication setup that I described early on to be able to share the data with that specific region. So it's still a point-to-point share, but there's a global directory. There's sort of a central repository of assets. Neil,
Hey, Vinay.
Sorry, go ahead.
Yeah, I was just going to ask. So with this kind of data mesh architecture, are you simply providing the infrastructure to allow all the sharing, or does Snowflake provide any analytics or learning capabilities that get applied to that data?
Yeah, that's a great question. We're not each of these industries, each of these use cases have very specific analytic requirements. So our approach has been to provide the platform, to provide the core features. So whether it's language-based features, SQL, Python, R, if you like to work in a specific language, we have native support for that language. And we are also developing industry-specific best practices for each of these areas. But really, it's about partnering with organizations that might have expertise in a specific area. So somebody that provides chip manufacturing analytics, would run their application on the Snowflake cloud and be able to access the data. Okay. So that's what we call the third-party tools in this particular example. And in closing, I wanted to touch on governance, because that is extremely important. So we think of governance in three phases. So understanding your data, knowing what it is, classifying it. So this means understanding what is restricted, what is sensitive. Whether it's PII, it's personally identifiable information about individuals, whether it's credit card, PCI type of information, is it GDPR protected? So classifying that information, tracking its data and usage, protecting it. So once you understand what the data is, you want to be able to mask, obfuscate, sensitive data. That's another aspect of it. And finally, still being able to collaborate and share that data. So getting the full potential of your data, making it easier to share and collaborate. So these are sort of the three principles. And in terms of features that you might want for each of these, knowing your data is all about tagging, providing tags, object tags, classification, understanding who has accessed the data, has run queries against it, who's modified it, having that full line of sight on the data. So this is traceability. This is about knowing your data. And then once you've done that, you want to be able to protect it. So anonymize the sensitive data, have policies on who can see what, mask data. So you might say that social security numbers or unique identifiers of that sort globally are always masked, right? You might have all email addresses being hashed as a policy. So you define a central policy. You figure out all the columns that have that particular policy relevant, and then you apply it. That's the idea. So there's no chance of anything being left out or missed in this situation. You might have external tokenizations, where customers who use Protegrity or Voltage or secure approved tokenization agencies. So you can interact with that. And then having done all that, you still want to be able to share the data. And that's where secure data sharing and some of the marketplace and exchange technologies we've talked about come in. So this is again platform and content. That's where we think we can sort of have the most value, and this is where we are. It's what we're hearing from our customers.
All right. Thank you. So we've had a couple actually presentations talking about, data meshes and data sharing. In your experience, can you speak to how Snowflake's data sharing might be slightly different from some of those other implementations?
Yeah, the question to ask about any sharing technology is, how much work do you have to do once you receive the data? So if you're getting a file, if you're getting a test data format file, you're getting a DICOM file in the medical imaging industry, any sort of formatted flat file, there's a significant amount of work that still has to happen that the receiver has to do when they receive it. We think it's much more efficient, much more useful if what you share is the insight, the actual curated insight, maybe the API where somebody can ask a question, send you data, have that data be enriched, right? So maybe the input could be a sort of a chip identifier number that is common, that is being established by a global agency, sort of like GTIN, which is a stamp on a specific identifier, so that everyone understands that it's the same identifier. So when you share the information, you can then enrich it with your own information, share it back. So that's the level of sharing we're talking about here. And then to be able to do that without worrying about which cloud, which region your consumers are in, and have that all happen at a reasonable cost. So where the cost of sharing locally or sharing remotely is sort of insignificant with the value. So that's the test we think that any data sharing type of architecture should have. Neil, I'll also mention a quick point about federated query systems, and that's kind of been the holy grail of this space, that you can take the processing to the data wherever it sits and have it all work. Our experience has been that there are a lot of issues with that performance, most specifically, but also reliable performance. So can you always consistently get the answer in a few seconds to be able to drive your consumer-facing application, or even a few minutes? And that tends to vary depending on where the data is and how the federated query is performing on that system. So it's kind of a lowest common denominator problem we've seen.
Thank you. Just a quick reminder, if everyone could fill out the poll. We got a few more questions here. Are Snowflake services restricted to cloud only? Do you provide any edge compute or localized compute?
No, we are cloud only at this point. So if you have anything on-prem, we would minimally require that to be loaded up into some cloud storage before we can either ingest it or access it via external table lookups.
Okay, and do you see kind of each company natively just kind of providing their data on the marketplace, or kind of in the idea of chiplets, how would you see somebody driving kind of this data sharing aspect? So who would be the owner of essentially, getting all these vendors on board and, kind of getting all this data centralized?
Yeah, I mean, it does typically take one or a few companies that really have a need in a specific area to drive this. So on the marketing side, we have, we've got just as an example, we have a set of key players, Disney, AT&T, and so on, who all come together and got some common data sets together and are driving that. On the manufacturing semicon side, we'd probably need to have a common set of data products that everyone would need. We're sort of looking for partners, absolutely, in that area. And typically what it does is it starts with somebody doing it for their own internal systems. So a company like Micron, for example, that has done it for their manufacturing analytics specifically. So they've led that, and they're now trying to monetize what they have there and put it up on the marketplace or put it up on localized exchange. I should point out that you don't. It's not either the public marketplace or internal. You can set up private exchanges. So just for example, Micron and all of their suppliers and their key customers can form a sort of a private marketplace and share data within that.
All right, I think you were just about time, and I don't see any other questions. So thank you, Vinay, for your work and your presentation today. Thanks.
I'd like to thank all the presenters and also thank all the sponsors who made this event possible, and their generosity covered the expenses, so everybody was able to attend without charge. Our diamond sponsor is Omcor with differentiations in technology, quality, and service. Our emerald sponsors are Adventest, voted #1 in ATE by the VLSI survey in 2001, and Synopsys, silicon to software. And then our Ruby sponsor, Tech Search International. So once again, if you have an opportunity to thank the sponsors, please do so to encourage them to help support future events and bring great information like we've had over the last 3 days here at Data and Test Road to Chiplets. And with that, I will wish everybody a good rest of your day. And thank you for joining us, and look forward to seeing you at a future MEPTech event. Thank you.